Hello there, and then welcome to a brand new video. This is Happy Beyond Numbers, where we learn maths the easy way. Now, by the end of this lesson, you'll be able to identify exponential equations. You should be able to solve equations using the laws of what? Indices. We'll be looking at two methods. Now, without much I say, let's quickly look into it. So when we talk of an exponential equation, then we simply mean it is an equation where the unknown, so usually your x, is an exponent, or it is a power, or is an index. You see, an example is you having 2 to the power x being what? 8. You realize that our x is an exponent, not the usual linear equations we have. You see, 5 raised to the power 2x is equal to what? 25. The x, or our unknown, is what? An exponent. This is what we call an exponential equation. And to solve this, we usually express both sides with the same base. Without doing this, you can't solve unless you use other methods such as logarithm or any other. But in this lesson, we are on indices, and hence we'll be looking at how to use indices to solve them. So let's look at the first method. Now, the first method has to do with when you have the same bases. You see, so for instance, if you have a to the power x being equal to a to the power y, then we say that since a and then a, that is on our left hand side and on our right hand side, we have the same base, all we do is we equate the exponents, and we say x is equal to y. You see, so let's look at what that means. So as an example over here, we have 2 raised to the power x, which is equal to what? 8. So 2 to the power x equals 8. You know 8 can be written as what? 2 raised to the power 3. You see? So the first thing we need to do is we rewrite our 8 over here so that it has the same base as this. So that we have 2 raised to the power x being equal to what? 2 to the power 3. Now, if you look at it carefully, they have the same base. You see? So anytime we have the same base, then we can say it implies that our x is equal to 3. We only use this if the bases are the same. You see? So let's try this other example over here, which is 3 raised to the power x plus 1 being equal to 27. So our solution, if you have 3 to the power x plus 1 being equal to 27, then we first of all have to rewrite our 27. So it also looks as a number with what? A base of 3. You see? So you ask yourself, is there any number that when you raise 3 to it as a power, you are going to get 27? Yes, there is. And that is 3. So on our left hand side, we have 3 raised to the power x plus 1 being equal to, so instead of our 27 now, we are rewriting it in its index form. So that it becomes 3 to the power 3. Now at this stage, we equate the exponent. So we say that since the bases are the same, then it implies that our x plus 1 is also equal to what? Our 3. You see? So at this stage now, all you want to do is to make your x the subject. Making x the subject, you have x being equal to your 3, which is maintained on the right hand side. Then your positive 1 moves to the other side to become what? A negative 1. If you want lessons on equations, you can look at a playlist on equations and you can be able to solve all of these linear equations. So x equals 3 minus 1, and making x the subject or solving, we have x being equal to what? 2. And that satisfies what you have over here. You see. Now let's look at one last example on this method. Now this last question here says 4 raised to the power x is equal to 1 over 16. You see, so let's see how we are going to go about it. We have 4 to the power x being equal to 1 over 16. We said our bases have to be what? The same. So you ask yourself, is there a way you can rewrite 16 so that it has an index notation whose base is 4? Yes, there is. So we have 4 to the power x. Then instead of 16, we write the 16 as 4 raised to the power what? 2. Because we know 4 squared gives us what? A 16. Now you realize that the base here is just a number, whilst this one looks like a fraction. You see, so we want to apply the law of indices that says if we have 1 over a to the power n, then it is evaluated as a raised to the power negative n. You see, you can look at the earlier videos in the playlist and you realize that we spoke about all of these laws. So in this case, that is what we want to what? Apply. Hence, this over here is actually going to be what? 1 over 4 squared is actually going to be 4 raised to the power a negative 2. You see, we can now rewrite our equation. So from this side, we have 4 raised to the power x, which is equal to, we have rewritten this as what we have over here. So it's equal to 4 raised to the power negative 2. Then since the bases are the same, we do what? We equate the exponent so that we say it implies that our x is equal to negative 2. And there is nothing else to be done. It has been solved as what? Simple as you see. Now the next one we'll be looking at, if is when you have what? Different bases, or having the exponent being a variable. So talking of different bases being a variable, having the variable, it is just an application of the first method. Simply convert both to have the same base if possible. So let's look at this example here. We have 2 to the power x, which is equal to 4 to the power x plus 1. Now, if you look at it carefully, our base here is what? 2. And that over here is 4. So we need to make the bases look the same. You see? So with 2 and then 4, which number do you think can be rewritten? Can be written so that it has a power which is equal to 2 and then has a power which is equal to, which will then be evaluated as 4. It is 2. And most importantly, we already have this 2 over here. But we know that 4 raised to the power, we know that 2 raised to the power 2 gives us 4. You see, we know 2 raised to the power 2 gives us 4. So all we do is, instead of this 4 over here, we are now going to rewrite it as this. So that on our left hand side, we still have our 2 raised to the power x. And it's equal to, instead of the 4, we are writing 2 raised to the power 2. This is the 4. You see, so it's 4 raised to the power x plus 1. You see, so all this we have here is the 4. And then the x plus 1 is still maintained as it is. Now we looked at a rule which says if you have a to the power m, and all this also has a power. You remember we said we multiply the what? Exponent. That is the same thing we want to apply over here. So that our left hand side still remains 2 raised to the power x is equal to, then we have our 2, and this 2 here is going to multiply all we have here, giving us 2 into bracket x plus 1. You see, we know 2 raised into bracket x plus 1. If we are to distribute the 2 over, we have 2x plus 2. That is what we are going to apply. You see, so we now have our 2 to the power x being equal to 2 raised to the power what? Our 2x, and then our 2. With this now, we can say the bases are the same. So if the bases are the same, all we need to do is we equate the exponent, so that this x here is equal to what you have here, 2x plus 2. The rest is what? Algebra. You see, so making x the subject, we have x, and then this now moves to the left hand side. So then we're going to get negative 2x. Then it's equal to our 2. X minus 2x gives us a negative x is equal to what? 2. We do not want negative x, but rather we want x. So all we need to do is to divide both sides by negative 1, so that this negative cancels out this. Then we are going to get our x being equal to 2 over negative 1 gives us a negative 2. And that becomes the solution to our question. So it is very simple. If you have the bases being different, all you need to do is make sure you rewrite them to look the same. If they look the same, you are easy to go. Let's solve one last example, after which I give some exercises for you to try. So looking at what we have here, the question says 9 to the power x plus 1 is equal to 3 to the power 2x plus 3. So we ask ourselves, is there a number we can express both 9 and 3 in? You see, and that is 3. Moreover, this here is already 3. But we know our 9 is equal to 3 squared. Hence, instead of our 9 here, we write it as what? 3 squared. So that we have our 3 squared, which is our 9. So 9 raised to the power x plus 1 is equal to 3 raised to the power 2x plus 3. If you look at it carefully, this is going to multiply, so that we have 2 into bracket x plus 1, which gives us 2x plus 2 as the new index. You see, so we have 3, then 2 times x, which gives us a 2x, and then 2 times 1, which will then give us a what? A positive 2, is equal to 3 raised to the power 2x plus 3. Now, if you look at it carefully, you realize that the bases are the same, and hence the rest is what? Your linear equation. So equating the exponent, since the bases are the same, then it implies that 2x plus 2 is equal to 2x plus 3. So for this last question here, we have 9 to the power 2x plus 1 is equal to 3 to the power 2x plus 3. Now what do? We have 9 being equal to what we have here on our right hand side. Okay, so the bases are not the same. We make sure they are the same, you see, and we can write them both as what? Base 3. We know 3 squared gives us 9. So instead of this 9, we are going to rewrite it as 3 squared. And this is our 9. So 9 raised to the power 2x plus 1 should be equal to 3 raised to the power 2x plus 3. Now we know from the laws that our index here is going to multiply all we have here. So that we have 3 raised to the power 2 times 2x. That gives us a 4x. And then 2 multiplying 1 gives us what? A positive 2. Should be equal to 3 raised to the power 2x plus 3. Now that we have our bases being the same, we do what? We equate the exponents, so that we are going to have what? 4x plus 2 being equal to 2x plus 3. You see that we have just ignored the bases. Why? Because they are the same. And that is the main reason why we made sure they were the same, so that we can equate the exponent. So with that done, we can say our 4x minus 2x. Why minus 2x? We are taking this to the other side. And over here it is positive. So it moves transposed towards negative. So minus 2x is equal to 3 minus 2. That is this 3 here, then minus 2. And 4x minus 2x gives us a 2x. So we have 2x being equal to 1. Making the x the subject, we are going to divide both sides by 2, so that we have our x being equal to what? 1 over 2. And that is our final answer. So this is how far this video is going to go. Now all we are saying is, if you want to solve exponential equations, make sure both sides of the equation have the same base. So when the bases differ, just try converting them into what? A common base, and you are good to go. So this is the end of this lesson, and I'm going to leave some exercises for you to try. So these are two sets of questions you can try just to test your understanding. The first one here is when you have the equation on just the question has been changed, so change your outro. So these here are two sets of questions you can try on your own. The first one being application of the first method, and then the second one is what? When you have the variables on both sides. Have beyond numbers, where we learn maths the easy way. I do hope this video was helpful. See you in our next lesson. Bye.